Good morning, ladies and gentlemen, and welcome to the optics unit. Okay, so first we're going to start off by looking at page 341. What is the law of reflection and what does normal mean?
See if you can extract that from the reading. And there's a link to the book, right?
Yeah, we'll put it in above here. Okay, so go ahead and find those words and read about it. What do they mean? Okay, what is this? What does it mean? Okay, so now that you've done that, okay, check your work with mine. Normal is a line perpendicular to a surface at a point on the surface. Now, why do we say a point on the surface? Well, not all surfaces are flat, right? Sometimes they're curved, and so that helps us down the road.
And we encountered normal back when we were doing friction.
Yeah, yes, we did. You guys are familiar with that idea.
Yeah.
Definitions. We have our incident or incoming wave to a surface. Okay, so incidence, incoming. Okay, a little
I.
Reflected, abbreviated by RL, is what bounces back from the surface.
Yeah, and what we're going to be looking at is light rays, beams of light.
Yes.
And you have a surface, you got the one that's coming in, you got the one that bounces off, and then
we have the one that bends as it passes through the surface, and we call that refracted.
Yeah.
And we're going to abbreviate that with RR, refracted. Yeah. Okay, so incident, reflected, refracted. Oh, and then, no, I don't need it today. Okay, so how do you use this? So this is our protractor, our friend the protractor. And when we use a protractor, we need to line it up correctly. This is not the correct way to line it up.
Yep.
Can you figure out what's going on here? What's going wrong?
yeah.
Okay, so what should it look like? Okay, this is how you do this. Okay, so we want to be lining up the
Vertex.
the vertex. Yeah, I'm like, what is that?
I know, math words.
with the center here. And the problem with this one was that it wasn't lined up. It was over here. We want to line up right here in the center. And then you can read the angle here, okay, from the base. But you could also read it from the other side.
And there, on protractors, there's almost always two sets of numbers. One if you measure from the left, the other from the right.
Yes. Okay, so let's talk about the law of reflection. So the law of reflection measured from the normal. Oh yeah, the normal is this thing, right?
Yeah, perpendicular.
Perpendicular to a point on the surface. Measured from the normal, the angle of the incident ray equals the angle of the reflected ray. Okay.
And then here's an equation that says the same thing.
Okay. And so we've got our incident ray coming in. It hits the surface at that point. That's that perpendicular, and it's going to leave at what angle? An angle that's exactly equal to the angle that it came in from the perpendicular.
Yeah, and if you've played pool or billiards, you have some experience with this. And the key thing going forward is all angles are measured from the normal. You don't measure from the surface.
Yeah, not
you
from
measure
here
it
to
from
there.
the perpendicular.
Boop or boop.
All right.
Seems. Okay. All right, let's go ahead and take a look at our lab. Here's looking at you. Okay, so over here. All right, so I'm gonna go to this side actually. All right, so first things first, you guys are gonna answer this question. Before we start, go ahead and define normal.
Yep.
Okay.
So you have this piece of paper, right?
Yes. Yeah. This will be on the assignment. Okay. So it says, what do we have here? It looks like we've got something similar to this, right? We've got the setup. I'm gonna go ahead and read through this just to give them some background here. So the optical disc is put in front of the experimental lamp. This is the optical disc right here.
It's a protractor with no numbers on it.
And this is our lamp.
Yep.
Okay. And the single slit is mounted on the rectangular opening. Now, if you guys were to come around here, thanks, Mr. Boykin. When we turn our lamp on, okay, you can see that's what we're talking about, our single slit right there.
Yes, ma'am.
Okay. All right. The single slit is mounted on the opening. Place the plane mirror on the block. So here is our plane mirror right here. And you can see it's got a mirror on it. It's a mirror. And plane mirror is just a type of mirror. I'm gonna get that.
Well, it's like the geometric two-dimensional surface.
A plane, right?
Yeah.
Okay, so I'm locating it on the center of the optic disc, and locate it with its face on a line between the hash marks. So here are the hash marks. We've done that. I might make it look a little bit better here in a second.
It looks pretty good right now.
Spot on?
Yeah.
Okay, the optical disc is an unmarked protractor. Mr. Boykin just said that. Shine the light beam to the center of the optical disc. Measure the angle of incidence and the angle of refraction from the normal.
And there's some places there for you to record data. So we're going to do the thing for you. Let me make it dark here.
Okay. All right, so let's see. I'm gonna go ahead and try and get it right on the money there. And move this up ever so slightly.
So everything's got to be lined up. It's got to be right on the line. You got to hit right at the perpendicular there at the normal.
Okay. And I think we're good there.
Okay, the angle of incidence. Where do you measure that from?
From our normal right here, and this is our normal right there. That line. So we're gonna go. They're by 10. It's 10, 20, 30.
So the angle of incidence is 30 degrees.
Okay, so for trial one, I'm gonna go ahead and write 30 degrees right there. I don't know if you can see that.
Yeah, it doesn't matter.
Okay.
They can write it down on theirs.
And then over here, 10, 20, it looks like it's at 30 as well, right on the money. Okay, so for my next one, I'm gonna make it a little bit steeper. Let's come maybe out here a little bit.
You know, what I recommend is you leave the box there. The wires will come out.
Stay, okay. All right, so let's go ahead and go out.
A bigger angle.
I'm not even gonna go. I'm gonna try. No, we'll go put this one right here. Okay. Okay, I think I got it right there.
Yeah, you got to line things up so it's hitting exactly in the center and you're over the angle that you want. Okay, what's our angle of incidence?
Okay, so incidence is going to be measured from here to there. Okay, so that's going to be, I think this is 30, right?
That's 30.
So that's 40, that's 50.
So the angle of incidence is 50 degrees.
Okay, and then over here, again, we've got 10, 20, 30, 40, 50.
The angle of reflection is 50 degrees. Let's get some light on the subject.
All right, so hopefully you guys have something that looks like this. Next question, how does this observation support the law of reflection?
That's your job.
You guys got that. Okay, so next, place a scrap of paper in front of the surface of the plane mirror. Shine the beam of light on the paper. Is there a reflection?
There's a little piece of paper right here.
Okay, so let's do this.
Okay, now I noticed there's a puddle of light right here that wasn't there before. If you take the paper away, that puddle of light goes away. So there is a reflection off the paper.
Oh, do you guys see that? It's like right there. Right?
Okay, that's a different kind of it's reflecting off the paper, but we don't get a nice straight line, do we?
So the answer for this one is yes. Yes, there is a reflection. You guys saw there was like that puddle of light right in front of it there. Now it says remove the paper, allowing the beam to shine on the mirror, replace the paper. How are the two reflections different? That is for you to answer. Okay, so here's looking at you. Check, done. Let's talk about different types of reflection. So we have regular reflection, which is...
It depends on what kind of surface you're looking at.
Yeah, we're just going to call it a shiny surface. So the plane mirror is a shiny surface.
Right.
It's smooth, it's shiny. A diffuse reflection, for our first two trials, we saw a regular reflection then.
Yeah.
For a diffuse reflection, we're dealing with a rough surface.
Yeah.
Our paper is considered a rough surface.
Yeah.
So, and also, before you went like this, right, Mr. Morgan? Right? Can you see that shiny spot right there?
You can see the reflection.
Right? Okay.
No, it's good. It's a reflection of the projector here.
And so what happens when I bring my projector screen down that Mr.
goes
Boykin
away.
bought 23 years ago, 24 years ago? It goes away, right? And why is that? Well, we're dealing with a different surface. this is a shiny surface.
The board is a shiny surface.
And
Yeah.
it's a regular reflection, whereas we're seeing a diffuse reflection.
And
on
rub
a
your
rough
fingernails on the.
surface, right?
Yeah, it's rough.
Okay. Here is some visuals of what it looks like. So when we're looking at our plane mirror, we have light rays coming in, our incident ray coming in, and it's reflecting.
It obeys the law of reflection.
Yeah, exactly. Equal from the on either side of the perpendicular. The law of reflection. You see that for each ray.
Yeah.
Okay? Let's look over here. So we're still obeying the law of reflection, right? This light ray comes in right here and reflects off there. Our normal is right there. Okay, let's go with this one right here. It comes in, our normal is right here. It bounces off this direction. Okay.
And so, yeah, it's a rough surface. What do we know that has a rough surface?
Okay, so why does Mark Cavendish have a famous cyclist? What happened to his leg there?
Well, his spandex shorts are ripped, and that's a strawberry for days.
Yeah, that's pretty.
He must have come off the bike and scraped over that rough road.
Yeah, and so the road is rough. And at night, when we are driving, I'll draw my car here with this is my light right there.
Yeah.
The road is actually really rough.
Yep.
Right? And so when our lights come in, like this, bada boom, some of them bounce off this way and we can't really see them, but some of them are gonna bounce right here and right back to us here.
Yep.
Off that normal right there.
And so you can see the road at night because it's rough, and light reflects back into your eyes from the headlights.
Obeying the law of reflection.
But there's a problem when it's wet.
Yeah, when it's wet, it acts now like a plane, like a plane mirror, a smooth, shiny surface, right? And it's just like this. So what happens is, okay, light's coming in, and it just hits right off like that.
Yep. And
Right.
so at night, the road is much blacker when it's wet than if it's dry.
And it's hard to see. And if you drive, you have experience with this. And Boykin was telling me about his knowledge of Bot's dots, right? You guys see these dots on here?
Yeah, those are the dots they put on the road that are raised above the surface.
Yeah, and not only do they, as you're moving over, if you're falling asleep, do they wake you up?
Thump, thump, thump,
Yeah,
thump.
but they also act as, they just sit here, okay, and then they obey that law of reflection and help you see the road.
And they'll reflect that, so you can tell where the lane is.
And those are really important. Okay, so that's all we've got for today. Your homework is going to be to read page 699 through 702, and we'll start tomorrow with a lab, another one.